now we are in chapter 1, so 1.1. All right, let's start this pen thing, and let's see what's going on here. So 1.1, the real number system, Now before that, we have already got into the rational numbers, which is in chapter 3. Okay, so now for the numbers, we have different names for different type of numbers. Natural numbers. Well, human beings started just counting. Of course, it's very natural. You count 1, 2, 3. And so therefore, the concept of zero was not that straightforward or easy even to be accepted. Because if, for trade, if you give me one chicken and then I give you a sack of potatoes, this kind of trading. So what do you mean that I give you 0 and you give me back something? So 0 is interesting, but 0 was invented and accepted. So the numbers with all whole numbers, positive whole numbers, but including 0, that are called whole numbers. And then we move on to recognize negative numbers. And so then there's still whole numbers, but the negative positive whole numbers including 0, and we call them integers. Now the next one, we progressed ourselves onto so-called rational numbers. Now this time, decimals, fractions, negative fractions, and even roots, radical, square roots of 4, and a negative square roots of 9. And these numbers, take a look at here, even the repeating decimals, they all come into our reality, and then they form rational numbers. And then, believe it or not, we discovered irrational numbers. All right, so the interesting thing is that we have this box. Now today, with the students that are so-called face-to-face with me, I didn't even have to teach anything. So everybody knows all these numbers, and they all drew these boxes by themselves. So take a look at this box, right? Unfortunately, with the people that in the remote learning, I cannot get you to draw these boxes by yourself. So believe me, you definitely can do this by yourself. So this box is a rational number, and all these other number is within these boxes. They're overlapping from the smallest set, and then the set is getting larger and larger, and to this final box, which is a rational number. Now this box and the rational number, they have no overlapping whatsoever because they are absolutely different numbers, different type of numbers. So these two boxes. Now the more interesting question is that this box here, the rational numbers, and this box here, the irrational numbers. I think I kind of explored this question before. Which box, in fact, is larger? In other words, are there more irrational numbers than rational numbers? Well, today we ask the same question, and the student says, well, they're both infinite numbers of rational numbers in this box, infinite numbers of irrational numbers in this box. So we simply cannot compare. Really? Well, yes, we can. So for students that more interested in this topic, you can explore more about how can we count irrational numbers, or can we count rational numbers? If they're both countable, well, then do they mean they're the same size? If one is countable, the other one is not, then what does that mean? One set is larger than the other set? This kind of question is interesting. All right, so now these two boxes make this whole box that is called the real numbers. Okay, now some students, of course, also know besides real numbers is any other type of numbers? Yes, they are. So there's another box, which is unreal numbers. Well, unreal numbers, but another word to say complex numbers, imaginary numbers. Yeah, that's completely different box over here. For our grade level and even the secondary level study of mathematics, we don't really touch this box. This box starts with the first, this kind of number we encountered. It's like, wow, what is that? And that is a starting point of this box. Now, for your exercise set, I find this question is very interesting. Question number 1. All right. So this is true or false. It's pretty much like kind of like the logics. All right. So have some fun with it.